So now that we know what prime numbers are, let's try to know, how do you know if a number is prime? Well, we know that a prime number is a number that can only be divided by itself and 1, which means that it's a number that cannot be divided by any number except itself and 1. So the long way to do it would be to check if your number cannot be divided by any of the numbers smaller than itself. But if you had a number like 137, that would take a very, very, very long time. There's no secret to it, I'm sorry. You're going to have to check if the number is divisible by any of the numbers under it. But there are quick ways you can know, or try to know, if it works or not. So there are ways you can quickly identify some cases that don't work. And the first is if the number is divisible by 2. Because we know that all numbers that are going to be divisible by 2 won't be prime. And we know that all numbers that are divisible by 2 are even numbers. So all even numbers, except for 2 itself, are not primes. And 2 is an exception to that because if you say, okay, all even numbers are divisible by 2, so 2 would be divisible by 2. But in this case, divided by 2 would be divided by itself, so that wouldn't count. So that's the first case. All even numbers except for 2 are not prime. Because we know how to find even numbers. It's all the numbers so that would end in 0, 2, 4, 6, or 8. The next quick ones we can find are all the numbers that are divisible by 5. So all numbers that are divisible by 5 are going to end in 5 or 0. So that's the second case. So all numbers that end in 5 or 0, because those would be divisible by 5. The next quick one we can find are all the numbers that are divisible by 3, because we know how to find those easily. All numbers divisible by 3. Divisible by 3. Except 3 itself. Again, except 3. So all numbers that are divisible by 3, so that would be all numbers where the sum of its digits is divisible by 3. So all numbers, so where the sum of the digits is divisible by 3. So that's that case here. So all the numbers where the sum of the digits is divisible by 3. So that's what another quick set of numbers you can find. However, for other numbers, it's a little bit more complicated. So if you had a number that is prime, so you say if it's not divisible by 3, if it's not divisible by 5, and it's not divisible by 2, that doesn't mean it is prime. It just means that those cases don't work. So how would you find if it really is prime? Well, unfortunately, as I said, there is no secret and you have to go through them all. But there is a couple things that make it a lot easier. First, you don't have to do them all. You just have to do all of them up to the root of your number. Why? Well, we say, for example, number 12. We say the root of 12 times root 12 is equal to 12. These are identical. So it's twice the same value. Identical. Same value. Same value. Identical equals same value. So if we take any number that would be smaller, such as, so if we take a smaller number, such as maybe, let's take, for example, 3, and we multiply it by something to get to 12, this something here is going to have to be bigger. So that number is going to have to be bigger than root 12. And in this case, it would be 4, which is bigger than root 12. So what it means is, anytime you're going to have a number that is divisible by 12, it's going to have to be multiplied by something else to equal 12. So it's going to be multiplied by a bigger one. So you only have to check up to the ones that are identical, because if you were to find one that would be bigger, it'd have to be multiplied by a smaller one, and if you haven't found a smaller one yet, that means that there is no bigger one after that. Well, so it's actually, you're just doing it twice. So you only have to check up to root 12. So only have to check, let me write that here. So that's another thing you can do. And the next thing that makes our life a lot easier is you only have to check the other prime numbers. Why, you may ask? Well, let's take our example of 12, sorry. Let's take our example of 12 again. So we say, okay, well, let's check if it's going to, so let's say we go down, so we know it's not 11, 12, 10 does not work, 9, 8, 7, 6. We get to 12 divided by 6. 12 divided by 6 is equal to 2. Uh-oh, the number isn't prime. But what we really did is 6 itself isn't prime, which means that 6 is actually divisible by 3 and by 2. And those here are prime numbers. So anytime you're going to divide by a non-prime number, it's going to be able to be divided by another number, and that number is going to be able to be divided by another number, and so on, until you get to a prime number that can't be divided by a smaller number. So actually, you're just doing this repetitively, because if you had just done 12 divided by 3, 12 divided by 3, which is 4, you would have found out that it isn't divisible. Instead of doing 12 divided by 6, which 6 is divisible by 3, so 12 has to be divisible by 3. So you only have to check if divisible by prime numbers. So that makes our life a lot easier. Let's do a couple of examples, and let's see. If I tell you, for example, number 72. Let's see. It is divisible by 2. Divisible by 2. By 2. So not prime. So this is not prime. Not prime. That's an easy one. Let's take 71. So it's not divisible by 2. We can do it step by step. Not divisible. Actually, so not divisible by 2. That means divisible in my life. So not divisible by 2. Okay, so let's try if it's divisible by 5, which it isn't. It doesn't end in a 5. So not divisible by 5. So let's check if it's divisible by 3. We do 7 plus 1, 8. So not divisible by 3. So now we get to this annoying situation where you have to check it all. Now, what is the square root of 71? Let's check. So square root of 71, it's 8.42. So we're going to round up to 9 to make sure we cover them all. And we're going to check all the prime numbers up to 9. So, is it divisible by 2? No. Is it divisible by 3? No. Is it divisible by 5? No. Is it divisible by 7? No. Not divisible by 7. Divisible by 7. So we know it's actually prime. So here we've just found out it is prime. So to sum it all up, if you want to know if a number is prime, you have to make sure that it isn't divisible by 2, 3, or 5. Those are the easy ones. And then if it still isn't divisible by one of those, you need to make sure that it isn't divisible by any of the prime numbers that are smaller than its square root.